Hello and welcome back to Math 121. This is a video over section 2.2. We're going to be talking about functions and their graphs part 2. So what we're going to do is talk a little bit more about identifying intervals where functions are increasing or decreasing or when they're constant. We're going to be able to find maximums and minimums, identify even or odd functions. We're going to understand and use piecewise functions. This is always pretty hard. And then we're going to use the difference quotient, okay? So let's quickly talk about what it means when a function is increasing or decreasing. So let's talk about this, increasing and decreasing. All right, so let's just think about a graph, okay? And I'm going to graph this function like so, kind of similar to what we had. As we move, and so I want you to write this down. So as we move across the graph, as we move across, I might have spelled that wrong, the graph, there's no spell check when I'm just writing. As we move across the graph from left to right, all right, so from left to right, the function increases if the graph goes up, okay, and the function decreases if the graph goes down. All right, so the way I kind of think about it is, if I'm on a bike, all right, and if I'm biking up the hill, this is me on a bike, okay? If I'm going up the hill, we are increasing. Okay, and then we hit a maximum height, and then we change to decreasing. Okay, so this here is when we're decreasing. Okay, and then we go back to here and we go increasing. So as you move along your graph, okay, are you going up the hill or are you going down the hill? So if you're going up the hill, the function is increasing. If you're going downhill, your function is decreasing, okay? And so that allows us to talk about maximums and minimums, okay? So maximum and minimums, okay? And so a maximum is where the graph changes from increasing to decreasing, okay, and those are the symbols that I use to show increasing and decreasing. And a minimum occurs when you go from decreasing to increasing, okay, and that's where those occur, all right? So that's what I've got. So on this graph, all right, what I would do, and you just kind of have to think about like a mountaintop, all right? So this right here is a maximum, and this point right here is a minimum, okay? And that's where, just think of like your mountaintops and your valleys, okay? So when you get to the top of a mountain, that's your maximum height. So you're walking up, you're going down. Okay, same thing with a valley. If you go down to the valley, it's your minimum height, and then you continue to go up. Okay, so that's how we look at those, all right? Okay, so let's talk about even and odd functions. Let me kind of get my bearings here, okay? All right, so a function is even. All right, so let's talk about even functions first. So an even function, and let's just say this. I'm going to give you an example of an even function. F of x is equal to, say, x squared plus 2, okay? Now, one way to do this is to say to yourself, all right, if I plug in, say, f of 1, okay, let me plug that in and I get 1 squared plus 2. So f of 1 is going to give me 1 plus 2, so f of 1 is equal to 3. Okay? Now, a function is even if I plug in the opposite x value. So here I plugged in x is 1, okay? And then if I plug in negative 1, okay, I should get the same y value. So if I take negative 1 and square it, add 2, f of negative 1 plus, is equal to negative 1 times negative 1, which is positive 1, plus 2. And so we get f of negative 1 is equal to 3. All right, so my function is even, all right? And here's how I know this. And this is because if you plug in an x value and its opposite, okay, I might have spelled that wrong too. If you plug in an x value and its opposite value, okay, so I plugged in positive 1 and then I plugged in negative 1. If you plug in the x value and its opposite and get the same y value, then the function is even. Okay. Now, I could also say this, all right, you could also plug in, if my function is f of x is equal to x squared plus 2, I could also do this, okay? I have my positive x value. Here's my function. If I plug in a negative x, okay, here's how you actually really determine to see what you get. Then you get this. You get negative x squared and then plus 2. So if I plug in f of negative x, and I get negative x squared. So negative x times negative x plus 2. Negative x times negative x, negative times negative is a positive. So this is going to give me f of negative x is equal to positive x squared plus 2. Okay? So if I have a function and I plug in negative x and get the same function, then, because those are the same, then it's even. Okay? And that's how I determine an even function, okay? All right, let's talk about an odd function. Okay, let me do that up over here. Okay, so odd function. So write small, okay? An odd function is a similar function, so I'm just going to do f of x is equal to x cubed. Okay, now if I plug in 1, all right, let's plug in 2. All right, that means I'm going to take 2 and cube it, okay? And so f of 2 means I'm going to do 2 times 2 times 2. So f of 2 gives me positive 8. Okay, now my function is odd, all right, because if I plug in the opposite x value, so I plug in 2, the opposite x value is negative 2. If I plug that in, I'm going to get negative 2 cubed. Now what's going to happen is, all right, I'm going to get negative 2 times negative 2 times negative 2. So negative 2 times negative 2 is positive 4 times negative 2 again gives me negative 8. Okay, so here's how I know that this is odd. Okay, if you plug in an x value and its opposite, okay, you should get opposite y values. And that's how you know that you have an odd function. Okay, now you could also do, the other thing where you did, if f of x is equal to x cubed and you plug in negative x into that function, okay, then you get negative x quantity cubed. And when you do that, f of negative x, that's going to give you negative x times negative x times negative x. Now, if I multiply 3 negatives together, okay, I'm going to get a negative number. All right, so I get f of negative x is equal to negative x cubed. Okay, and so what happens is that, what I'm looking for is that, I have my function. If my function is odd, then my entire function is going to be negative. Okay, so if it's odd, so if a function is odd and you plug in negative x, the entire function will become negative. Okay, whereas when you had an even function is negative. When you had an even function, when you do that, that one is just, you get the same thing when you plug in negative x. Okay, but if you plug in negative x into an odd function, you get the opposite function. The whole thing becomes negative. All right. Now, let's quickly talk about where these are symmetric. So even functions, all right, even functions, okay, are symmetric with the y-axis. So if I graph this function here, x squared plus 2, all right, that's just going to be a parabola moved up 2 units, okay? This is symmetric to the y-axis, okay? So, and that's why, if I plug in positive 1, what did I get? 3. Okay, if I plug in negative 1, I get 3 as well. All right, and that's how I know we have an even function. Okay, an odd function is, on y cubed, we had, it's symmetric with respect to the origin. Okay, and so if I plug in 2, remember we get 8. All right, if I plug in negative 2, we get negative 8. Okay, my graph doesn't look very good, but you get the idea. All right, and so that's how I know. All right, so that's that. All right, we'll talk about piecewise functions, on the next page, but let's go ahead and do these practice problems real quick and to determine, state the intervals on which the given function is increasing, decreasing, or constant. So increasing, okay, I'm going to color that in red. Decreasing, we're going to color that in green. Okay, and constant, we would color that part of the graph in yellow. Okay, constant means that it just goes straight across. Okay, I think I spelled across correctly there. We'll see. I don't know. All right, so when it's increasing, all right, so when am I going up the hill? Okay, and that's going to be here to here. Okay. And then we're going to go up the hill from here to here. All right. And then we're going to be decreasing from here to here. That's where we're going down the hill. So the question is, it wants us to find the intervals on which the function is doing that. All right. So when it wants us to find intervals, okay, intervals means the x values. All right, so intervals are the x values where this is happening. Okay, x values. Okay, so when we're increasing, okay, so let's write this. We are increasing, okay, over the intervals, and I'm just going to color the graph in, all right, in red, where it's increasing. So the graph is increasing from negative infinity until we get to negative 1, okay? So we're increasing over that interval of the x values from negative infinity to negative 1, okay? And then we're also increasing, all right, from positive 1 all the way to infinity, okay? And that's how I kind of have to look at that. So I start at positive 1. So let's write that. And I write this in interval notation. I say that this is unioned with 1 to positive infinity. Okay. Now we're decreasing in between those two, in between negative 1 and 1. All right. So in between negative 1 and 1, all right, here's where we're decreasing, okay, those x values. And so we're decreasing between negative 1 and 1. Okay. Now if we can also locate our maximums and minimums, okay, I'm just going to do that on the graph. This point right here is a max. This point right here is a minimum. Now, it didn't ask us to do that, but that's how we should identify where those are. So we have to be able to look at a graph and determine where are we increasing, where are we decreasing, okay? And then where is that happening on the x-axis, okay? So for what x values are we increasing? For what x values are we decreasing? And that's how we answer that. All right, so now let's go ahead and take a look at these problems down here where it talks about determine whether each of the following function is even, odd, or neither. So let's take a look at this first one. And one way that you can do this is simply just by plugging in negative x into that function. Okay, and when I plug that in, I get negative x quantity squared plus 6. Okay, and we want to see what happens. All right, and so if I take negative x squared, negative x times negative x plus 6, okay, and that's equal to f of negative x, then negative times negative gives me a positive. Okay, so I get x squared plus 6. Okay, so I get f of negative x is equal to my original function. Okay, therefore, this is even. Okay, now what we also could do, all right, is we could plug in, say, f of 1, all right, and that's going to give me 1 squared plus 6. So f of 1 is equal to 1 plus 6. So f of 1 is equal to 7. All right, now if I plug in negative 1, okay, then I should get 7 as a result if it's even. All right, so if I plug in 1 squared plus 6, f of negative 1 is equal to, negative 1. Negative 1 times negative 1 plus 6. Negative 1 times negative 1 is positive 1 plus 6. So f of negative 1 is equal to 7. All right, so we are, in fact, even. Okay, let's take a look at the next one. G of x is equal to 7x cubed minus x. So let's just plug in 1, see what happens. All right. I'm going to get 7 times 1 cubed minus 1. So g of 1 is equal to, 1 cubed is just 1, so 7 minus 1 is going to give me 6. All right, so g of 1 is equal to 6. Now what I want to have happen, all right, let's just see what happens when we plug in negative 1. All right, and then we'll see what we get. So I get 7 times negative 1 cubed minus a negative 1. Okay, and so g of negative 1 is equal to, negative 1 cubed is going to give me, what is that? Negative 1. All right, so I get 7 times negative 1, and then I get plus 1. All right, so then this is going to give me negative 7 and then plus 1. So g of negative 1 is going to give me negative 6. Okay, so what happens is, because 6 is opposite, because these are opposites, okay, all right, my y values are opposites, okay, opposite y values, all right, because those are opposites, then I can say that we have an odd function, okay, and that's how I can tell. All right, you could also plug in negative x into this, but I assume just plug in the numbers. I think that's fine. Let's take a look at h of x here. All right, let's plug in 1. So I get 1 to the 5th plus 1. So h of 1 is equal to 1 to the 5th is just 1 plus 1. So h of 1 is equal to 2. All right, let's plug in negative 1 and see what happens. All right, so I plug in negative 1. I get negative 1 to the 5th plus 1. Now h of negative 1, all right, so negative 1 to the 5th, if I'm raising it to an odd power, it's going to remain negative. So I get negative 1 and then plus 1. So h of negative 1 is equal to 0. So because these are not opposite, nor are they the same, this function is neither, and neither is NEI, neither odd or even. Okay? And that's the answer on that. All right, so hopefully that makes a little bit of sense. Yeah, let's go to the next one. Okay, on this next one, we have this thing called a piecewise function, okay? And let's talk about what a piecewise function is, all right? So a piecewise, P-I-E, yep. Okay, so piecewise function, okay, is when you have multiple functions on the same graph for various intervals. All right, and I'm not going to go through like a serious explanation as to why. I'll show you how we get these graphs and what we're doing, but I'm not. You'll have homework questions where you have to graph these things. Okay, and I'll go through that with you guys. When we get to that. So what I want to do is take a look at this piecewise function here and its graph, okay? What I have is I have c of t is equal to 20, all right, the function 20, which is a horizontal line through 20, if t is between 0 and 60, okay? So in between 0 and 60 on the x-axis, I have the graph of 20, okay? Now, if t is greater than 60, so anything beyond 60, I use this function, 20 plus 0.4t, quantity t minus 60, okay? And we have this graph that goes like this. So what I have is I have multiple graphs. I have two different lines, okay, on the various intervals, okay? And that's essentially what a piecewise function is, all right? And so you have to say, all right, here's this graph, here's that graph, here is the domain, here is the interval in which it exists, okay? And then we have this one, this graph here over this interval, okay? And so that's how I figure that out, all right? So what they want us to do, it says use the function in example 3 to find and interpret each of the following. So we want to find c of 40 and we want to find c of 80. Now, when I'm finding c of 40, all right, and let me zoom in just a little bit. If I'm finding c of 40, 40 is my x value, okay? So I'm going to use this value here, all right? And I can answer this question on the graph. And I can say, all right, well, when t is 40, my y value is 60, okay? I could also use this part of the graph too, okay? And understand that anytime I'm plugging in any number for t that's between 0 and 60, it's going to be 20, or 20, not 60. What am I doing? God. Okay, so 20. Yeah, I got 60 mixed up because we're using this number 60. Okay, now if I do the same thing for the second one, all right, if I wanted to find c of 80, okay, my question is right here, I can't really tell what that number is when t is 80. All right, so because 80 is larger than 60, okay, it fits in this domain, I'm going to use this function. So let me plug it in, all right, and let's see what we get. So I'm going to do 20 plus 0.4 times 80 minus 60, just plugs 80 in. 80 minus 60 is 20, so I got 20 plus 0.4 times 20. Now if I do 0.4 times 20, I want to say that's 8. Boom! Okay, and so I get 20 plus 8 is equal to 28. So c of 80, okay, is going to equal 28. All right, and that's hard to notice from this graph. All right, now let's talk about what does all this stuff mean, okay? Now in this problem, it says that this function describes the cell phone plan. Okay, and what I'm thinking is this, because it doesn't really tell us, but for the first 60 minutes, okay, t is time, for the first 60 minutes, you're going to pay $20. After that, you're going to pay, any minute after 60, you're going to pay 40 cents per minute, okay? And so this is cost, and this is minutes. So for 40 minutes of cell phone use, you're going to use $20. You're going to pay $20. For 80 minutes of cell phone use, you're going to pay $28. And that's how we do that, okay? All right, let's go down to the next part, talk about the difference quotient, okay? So in this one, okay, it wants us to find f of x is equal to negative 2x squared plus x plus 5, all right? They give us this function f of x. They want us to calculate first a, which is f of x plus h. And then they give us this thing called the difference quotient. Now, this is going to seem very... what's the word? Strange and weird. But what I want you to understand is that this thing right here is the fundamental aspect of calculus, okay? Now, you may not go to calculus. You may go to calculus. If you do go to calculus, all right, you will use this all the time, and you will see this over and over and over and over again. And this is a very powerful thing that we are able to do, okay? But we want to simply just be able to figure out what this is. So let's start off with this. Let's start off with f of x plus h. So in part A, okay, if I wanted to find f of x plus h, then I'm going to plug in x plus h for my x values in my function. So I'm going to do this. I'm going to get negative 2 times x plus h quantity squared plus x plus h plus 5, okay? So that's f of x plus h. Now, what we want to do is we want to simplify this, okay? F of x plus h is going to equal, let me multiply this out first. I'm going to take negative 2 times x plus h squared is going to give me x squared plus 2xh plus h squared. Okay, I just foiled that, or did the box method. Okay, and then what I want to do is I want to add x, add h, and then add 5. Okay, now here I'm going to distribute my negative 2 into each of those. So f of x plus h is equal to negative 2x squared minus 4xh minus 2h squared. And then I'm going to add an x, add an h, and then add a 5. Now, I'm not able to combine any of these as like terms, okay? And I'm just treating x and h like variables, okay? And that's what we've got, all right? So that's my value for f of x plus h. Now what I want to do, okay, and I'm just going to make sure I write down f of x as well. That was negative 2x squared plus x plus 5, okay? Because I want to do part B, which is the difference quotient, all right? I want to do f of x plus h minus f of x all over h, okay? Now, when I do that, I'm going to plug that in. So when I plug in f of x plus h, I need to plug in this entire thing here. So watch what I do, okay? I'm going to do negative 2x squared minus 4xh minus 2h squared plus x plus h plus 5. That is my f of x plus h. Now I'm going to subtract f of x. Now when I subtract that quantity, okay, I'm going to put parentheses. I'm going to do negative 2x squared plus x plus 5. And this is going to be all over h. Now, okay, remember, this part here is my f of x plus h. This part here is f of x. Now, what I'm going to do is I'm going to distribute this negative, okay? And I want you to see what happens, okay? So the next step down, I'm going to get negative 2x squared minus 4xh minus 2h squared plus x plus h plus 5 plus 2x squared minus an x minus a 5, okay? Now take a look and see what happens, all right? I'm going to divide everything by h, all right? Now, in my numerator, negative 2x squared and positive 2x squared, those cancel out to 0. They add to zeros. All right? The next thing that I can do is I have this positive x and negative x. Those go away too. And then I have positive 5 and negative 5, and those are going to add to 0 as well. So now, think about what you have left, all right? We just have negative 4xh minus 2h squared all over h. Now, my objective at this point is to get rid of this h in my denominator. And this will always happen. If you're doing this correctly, this will always be the case. And what I'm going to do is I'm going to do I'm going to factor out an h in my numerator. And I'm left with negative 4x minus 2h, okay, all over h. These h's divide out, okay? So this step, if you don't get to this, you're doing it wrong, okay? This will always happen, okay? This will always happen. So then what you're left with, your answer is negative 4x minus 2h, okay? This is your answer, and this is what we're looking for. Now, I agree, this may have been something that you're like, all right, what is the purpose of this? I'm not going to get into that because that would require me getting into calculus, which I'm happy to do. I'm happy to talk to you guys about this and why this is so important. But what we are doing in this class right now is we are simply going over the fact of taking a function, okay, f of x, finding f of x plus h, okay, expanding that out, putting it into this difference quotient, and practicing the algebra that's involved in getting down to this point, okay? Because if you make it to calculus, then this will become a very important aspect of calculus and your ability to do this algebra, okay? So we cover it now, but that's all we're going to do with it. So all you need to be able to do is see this and identify f of x plus h, know what f of x is, plug it in, and then do the algebra and then simplify it down to what you need. So that's all I got. I hope you enjoyed this video. We'll talk to you soon. Thanks a lot. Bye.